Welcome to the lecture where we're going to solve some problems using the alligation method. And as you can see here, there are really two different kinds of alligation methods. We'll start with the alligation medial and then end up solving a lot of these using what's called an alligation alternative method. And we'll define both of those methods here in a minute. I guess just to set this whole lecture up, we're still in the middle of chapter 5, which is all about calculations involved in altering product strength. And you can't alter product strength without understanding the idea of concentration. This is all about altering the concentration of a product. So I'll just remind you that the strength of any drug preparation may be either increased or decreased by changing the proportion of active ingredient to the whole. That's this whole idea of concentration. Concentration expresses the amount of active ingredient to the whole of the product. Now, a preparation can be strengthened or made more concentrated in a couple of ways, either by just adding pure active ingredient, or alternatively, as you'll see in this chapter, by mixing it with a like preparation of greater strength. So adding a greater strength to a lower strength creates a strength in the middle. So it doesn't go higher than the higher strength, but it raises the lower strength when you combine the two to something in the middle. Okay? Now, oppositely or conversely, the strength of a preparation can actually be decreased or diluted by a couple of ways. You can reduce the concentration of a product by mixing it with just a pure diluent, or, like we said before, if you take a higher strength and mix it with a lower strength, it lowers the strength of the higher strength. In the end, the unique combination is something in the middle. And you'll see here, with this alligation methods, we're usually mixing a high strength with a low strength to create some sort of concentration in the middle. And you can calculate these relative amounts of high strength and low strength using these alligation formulas, either the medial method or the alternative method. So with that as a short introduction, let's get started by defining this idea of what is an alligation. Alligation is actually an arithmetical method of solving problems that involve mixing of solutions or mixtures of solids or semisolids that have different percent strengths. So let's illustrate that with the question down below, because this is where our intuitions sometimes fail us. So the question at the bottom, it says true or false. By mixing calculated amounts of 2% ointment with 10% ointment, if you combine those two together, a pharmacist can make a 12% ointment. Is that true or false? The answer is definitively false. And the reason our intuition fails us is that we look at the 2 and the 10% and we know there's active ingredient in there. We know there is a mass of drug. And remember, we've calculated mass. Mass is equal to a concentration times a quantity. So if we had a quantity of 2% and a quantity of 10%, clearly, times its concentration, there would be mass of drug. And if we add them together, you increase the mass of the drug. M1, mass 1, plus M2, mass 2, equals some new mass 3. And that is correct. But remember, we're not adding just pure active ingredient. We're adding a semi-solid or a solution that has an active ingredient diluted in some base. And so when we combine them, we are not only increasing the amount of active ingredient, we are increasing the overall volume or mass of the diluent or the base that it's in. So in the end, when you mix those, you always end up with some concentration somewhere in the middle. So 2%, whatever amount you have, plus 10%, whatever amount you calculate to have, and you mix those together, you can do calculations and figure out any relative amounts of those two, but the only concentrations you could create by combining the two is a concentration somewhere between 2% and 10%. So you can't go higher than the higher strength, nor would you go lower than the lower strength if you're adding two concentrations of the same drug together. Okay, so that's kind of the key idea behind that. And that's how you formulate and determine how much 2% and 10%, for example, to mix to make any concentration within the middle. The kinds of calculations you do to perform that would be alligations. So the two different alligation calculations that we're going to do here in a minute. The first one is called alligation medial. And this is a method where we'll use this, what they call a weighted average strength of the two concentrations together to make a new concentration. So we'll use this weighted average system. An alternative is the alligation alternative method, and it's the method I prefer. It's kind of a neat way of being able to calculate, and it involves matching two pairs of ingredients. Again, like my example below, one that's a higher strength and one that's a lower strength, and using this alligation alternative method, you can determine essentially the relative amounts of those two to add to get any desired concentration that you have. Okay, so just setting up that in this lecture, we'll do both. We'll do a lot of the same calculations in maybe more than one method, because again, you can answer these questions or solve these problems using either the medial method or the alligation alternative method, and we'll illustrate both of those. All right, our first question will involve calculations using the alligation medial method. So the problem reads, a pharmacist mixes 200 grams of a 10% weight per weight ichthymol ointment and 450 grams of a 5% weight per weight ichthymol ointment and 1,000 grams of petrolatum, which is used here as a diluent. And the question asks, what is the percentage of ichthymol in the finished product? And before we do our calculations, a little bit of background on ichthymol. As you can see on the picture on the top right here, it's kind of gross looking. It's also known by its more common name as a black drawing salve. It actually is supposed to be able to kind of pull things out of the skin. It's been used for many, many years, and it is actually a kind of gross smelling sulfonated derivative of shale oil. So anyways, there you have it. An interesting old product. So what we want to do is make a combination of three ingredients, this 10% weight per weight ichthymol, 5% weight per weight ichthymol, and then a certain amount of diluent in terms of the petrolatum. If we mix all those three things together, what is the final percentage of ichthymol in the finished product? Okay, so what would be our first step? All of these calculations are about concentration, and concentration is about the weight of active ingredient as it composes part of the whole, which is a larger amount. So let's start by figuring out, step one, determine the total weight of the product. Regardless of the source of the product, what will the final total weight be? Okay, so let's simply start by adding up the weights of the individual ingredients. And so don't multiply this. Hopefully I didn't make this confusing. Our first ingredient has 200 grams. Now the 200 grams comes from our 10% ointment. Then we also have 450 grams from our 5% ointment. And lastly, we have 1,000 grams from our diluent or our petrolatum. So if you take 200 plus 450 plus 1,000, the total weight of our product when everything is going to be combined is 1,650 grams. So step one was just to determine the total weight of the product. Step two will be to determine of that weight, how much of it will be our active ingredient, in this case, the ichthymol. To do that, we simply need to take the weight of each product that we're using times its concentration. And the concentrations we were given were as a percent weight per weight. So let's start with our first ingredient, which was the 10% weight per weight. And it says we are adding 200 grams of that. So if we start with 200 grams of that ointment times its concentration, which we said was 10%, which we would rewrite as 10 grams of ichthymol over 100 grams of that ointment. So if we multiply that out, the grams of ointment cancel, and we're just in grams of pure ichthymol. So 200 times 10 divided by 100 equals 20, and that would be grams of ichthymol. All right, we'll do that for the 5% weight per weight concentration. That one we started with 450 grams, so 450 grams times 5 grams divided by 100 grams gives us 22.5 grams, and again, the remaining units would be of pure ichthymol. And lastly, if we start with petrolatum, we started with 1,000 grams of that. Now, it didn't give us a percentage weight, but it's pure base. It has no drug, so it would be 0%. So if we multiply the 1,000 grams times 0%, or 0 over 100, we can see you get 0. Obviously, there is no ichthymol from the petrolatum. So, stopping there, let's add up all of the ichthymol we do have. So we would take the 20 grams from the 10% plus the 22.5 grams from the 5%, add those together, and the total amount of ichthymol that we have is 42.5 grams. Okay, we know how much total product we have, which was 1,650 grams, and we know of that weight, we have a total of 42.5 grams of ichthymol. So our last step was simply to determine the actual concentration or the final concentration of ichthymol in a product. To do that, all you got to do is take the total weight of ichthymol divided by the total weight of the product that it resides in times 100 to express it as a percent. So 42.5 divided by the 1650 times 100 gives us a final result of 2.58, and that would be percent. So to express the concentration of ichthymol in this new combined product, it contains a 2.58% weight per weight concentration of ichthymol. And that essentially is the answer to this question. And hopefully you think this is a pretty easy question, because it is an easy question. This is just to show you the process for doing the alligation medial method. The reason I say this one is easy is that we were given the amounts and concentrations of all of our ingredients, and we simply had to find the final percentage. What you'll see in some future calculations that we're going to do, it gets more difficult to use this method when you go backwards. That is, we know the final concentration we want to have, but then you try to figure out the relative amounts of your lower concentrations to get there, or your other concentrations, I should say. So we'll see that in a minute, but hopefully you thought that this was fairly straightforward process, and keep that in mind, because we're going to follow the same process, but we're going to have other variables that will make solving this type of calculation a little more difficult as we progress on. Our next question will introduce and do a partial question, but a good introduction for the alligation alternative method. So to read this question, it states, in what proportion should zinc oxide ointments of 5% weight per weight and 20% weight per weight strengths be mixed in order to make a 15% weight per weight ointment? So just to explain this question, if you look down below here, we have two different tube concentrations of zinc oxide ointment that are already made. One of them is 20% and the other one is 5%. So what we want to do is squish out just the right combination of the 20 and the right combination of the 5%, so that when we mix it all together, we end up with a 15% weight per weight volume in the end. Okay, so this is a perfect example of when you would want to do the alligation alternative. When you have a high strength to mix with a low strength, because you want something in the middle. And remember, with the alligation alternative method, you're always trying to find a concentration somewhere between your high strength and your low strength. Okay, so with this alligation alternative method, I really like this method because it's a visual method. Once you kind of understand the steps to follow, you can kind of set this up, and it's kind of the way you set it up visually kind of helps remind you how to do it. So remember, we have a high strength and a low strength. And the way that I like to show students how to do this is to always start with the high strength on top. So the highest strength that we have is the 20%. So let's put the 20% on top. And what I mean by that is we're going to write the low strength, in this case the 5%, on the bottom. So you'll notice directly below the 20%, I write the low strength, which is 5%. But I put some space between there, okay? So don't put them right below each other. So 20% on top, put some space, and then write 5%, the low strength, directly below it, but give some space in the middle. Because what goes in the middle is what we're trying to compound. In this sense, remember, the alligation alternative method is a method to compound something between a high strength and a low strength. In this case, what the concentration we want between those two is 15%. So let's put 15% directly in the middle between the 20 and the 5, but not directly below. We want it off to the right. So you'll notice we're forming kind of a triangle shape where we have the 20% on the top, directly below the 20%, but spaced down a little bit, is 5%. And then in the middle, which is the concentration we want to get out of this combination, so directly in the middle, but to the right, we put the target, which in this case is 15%. The reason we set it up this way is that we're going to draw some arrows. So let's draw some arrows going from the 20% down to the 15%, and from the 5% going up to the 15%. So this is what I mean by kind of forming this triangle shape. Now, let's keep going in the direction of the arrow. So if we keep going with the 20%, we drew an arrow going from 20% down to 15%, and then we go from 15% down in the same direction, so it ends up at the same level of the 5%. And this is the trick you've got to remember. In this procedure, you follow the arrows and you cross-subtract. And you always take the higher number minus the smaller number. It doesn't matter which one is the higher or the lower. Cross-subtract. So 20 minus 15 would be 5. So we would follow the arrows down and write the value of 5. Okay, and we follow the arrows down. So it's essentially about at the same level of the 5%. Now, let's do the same thing with the 5%, though. Following its arrows up to the 15%, we would follow it up again so that we have a value that we're going to write basically at the level of the 20%, going from the bottom left to the upper right. And so if we cross-subtract, we take the larger number 15 minus the smaller number 5, and that difference is 10. So we would write our value of 10 right below there, right up following the arrows up. What does that mean? Now, you'll notice then we had percents when we wrote down our first three numbers, the 20%, the 5%, and the 15%. But now that we have cross-subtracted and written our values down below there, we do not carry the units over. There are no units with these numbers. Essentially, it means parts. We have essentially determined on the top at the 20% where our value of 10 is. See the arrow going from left to right there. For the 20% concentration, we have just said we need 10 parts of whatever amount we're going to make to be the 20%. So the 10 goes with the 20%. Likewise, on the bottom, the 5 value down there goes with the 5%. So we need 5 parts out of our total to be 5% zinc oxide. Just like above there, we said we need 10 parts of the total weight to be 20% zinc oxide. So all we've done is cross-subtract, and remember the values that you cross-subtract end up matching up with the concentrations directly across from them. Okay, that's why, again, part of this is a very visual method. Now, we're almost done with answering this question, which is the proportion to mix the zinc oxide ointments. Remember, we have the individual parts, 10 parts of the 20% and the 5 parts of the 5%. The question is still out of how many? If we need, for example, 10 parts of the total weight to be 20% zinc oxide, how many total parts are there? Well, that's easy. Since the only two ingredients are either the 20% or the 5%, all you need to do is add up the total number of parts. So take your number 10 for the 20% plus the 5 for the 5%, add that together, and the total number of parts will be 15. So the final part to this question is simply to express the amounts of the 20% and the 5% as a proportion. And we said for the 20% concentration that we need 10 parts of the total weight to be 20%. So we need 10 out of a total of 15 parts to be 20% zinc oxide. Likewise, on the bottom, if we needed 5 out of the total number of parts to be 5%, then what we really mean is we need 5 parts out of a total of 15 parts to be the 5% zinc oxide. So the proportions that we've now set up, we can multiply this by any amount of ointment we want. This is still a general formula that says for whatever total weight you want, as long as 10/15ths of this is 20% and 5/15ths of this is 5%, then that will set the right proportion of those two concentration of ingredients such that the final concentration would be 15%, even though we haven't even specified an exact weight yet. So that essentially answers this question. And certainly you could reduce those fractions. So on top, 10/15ths, really, if we divide both the top and the bottom by 5, that is the same as 2/3. And on the bottom, if you divide the top and the bottom by 5, 5 divided by 5 is 1, 15 divided by 5 is 3. So essentially, this is showing you that 2/3 of whatever weight you need to make needs to be the 20%, and 1/3 needs to be 5%. If you mix that together, whatever the total amount of that weight will be, your final concentration would be 15% zinc oxide, which was what our target was in the question. Okay, I know what you're saying to yourself right now. You're saying to yourself, well, it's either why am I listening to this lecture, or besides that, does that really work? Does that alligation alternative method, that seems too simple? And it does work, and let me try to prove that to you. And we'll do it two ways. We'll first try to confirm our answers using the alligation medial method that we've already shown you in a previous example. And then we'll also do it using the algebra example that we've done before, where mass 1 plus mass 2 equals mass 3. Both of these methods will confirm that our alligation alternative method really does work. So let's start with the alligation medial. And if you remember from our one worked example so far, step 1 was to determine the total weight of all of the final product. Add everything together and what was the total weight of everything. What's a little bit weird about this, and I know students don't like this, is we don't have our weight in units of weight, like milligrams or grams or anything like that. what we have is we've expressed our answer in parts. And we can assign one part to be equal to a certain amount of weight. It's a relative amount. So while we haven't defined it in an exact weight, what we do know is that the total weight will be 10 parts of that weight will come from the 20%, and 5 parts will be coming from the 5%. So if we add 10 parts plus 5 parts, we have a total of 15 parts. So we know the total weight of our final product will have 15 parts as it relates to the individual ingredients. So we'll have 15 parts total. Okay? Step 2 then was to determine the actual weight of just the active ingredient, in this case zinc oxide. Now we get some zinc oxide from our 10 or 20%. We get some zinc oxide from the 5%. So let's figure out the total amount. So this is again where students don't like this idea, is that because we don't have units that'll cancel. Since our weight are in parts, we can't cancel our percent concentrations, but we can combine them. We'll just keep the units. So let's just start. With our 20%, we said that we were going to have 10 parts of our total weight be 20%. So 10 parts times 20% is 10 times 20, so that's 200. And since our units don't cancel, we'll just combine the units into parts percent. So 10 parts times 20% gives us 200 parts percent. All right. Let's do the same thing for the 5%. We said 5 parts out of the total weight was going to be the 5%. So 5 parts times 5% gives you 25 parts percent. All right. And while those are kind of weird units, bear with me on this, they are the same units, so we can add them up. So 200 parts percent plus 25 parts percent equals 225 parts percent. And that's essentially how we're expressing the total weight of the active ingredient, in this case, zinc oxide, in our final product. All right, and that was step 2. Step 3 was to simply determine the final concentration by taking the total weight of the zinc oxide, dividing it by the total weight of the product. All right. So what we calculated in step 2 is the active weight of our zinc oxide was 225 parts percent. Divide that by the total weight of the product, which was step 1, which we said was 15 parts. This is where a little bit of the magic comes in, is that our units can cancel, the units of parts. So parts percent divided by parts, the parts will cancel, and our final remaining unit will be percent. So if we just take our numbers, which is 225 divided by 15, our numeric answer is 15, and the remaining unit is percent. So we've basically proven using the Alligation Medial that if we take 10 parts of 20% plus 5 parts of 5%, add those together, the final concentration will be 15% of any weight that we compound. And so we have proven that our Alligation alternative method works by showing it works using the Alligation Medial. But some of you are a tough nut to crack. You may still not be convinced. So those of you that love algebra, and there are a few of you out there, myself included, let's prove it using the algebra method, using the M1 plus M2 equals M3 method. All right. So I've shown you up on top. Let's set up each of our C's and Q's to determine our M's. So we're going to say our C1, our concentration 1, is the 20% weight per weight. The quantity we have of that, we still have to stick in parts, so we have 10 parts of the 20%. So C1 times Q1 would be 20% times 10 parts. Okay. C2 will be our 5% times its quantity, which we are going to say is 5 parts. So M2 is going to be 5 times 5% times 5 parts. And lastly, C3, what we get in the end when we combine our mass 1 plus our mass 2, what we get in terms of the third resulting mass would be our concentration 3, which we don't know what the resulting concentration is. That's what we're trying to decide. But that will equal a quantity of, remember, quantity comes from the C1 and the C2. So our resulting final quantity would be 10 parts plus 5 parts, or essentially 15 parts. All right, so mass 3 is going to be some unknown X percent times 15 parts. And hopefully we've done enough of that practice that those setups of M1s and 2s and 3s make sense. So now if we go back and say that, what we've got here in terms of mass is if I take my mass 1 plus my mass 2, mix those together, I get my final mass 3. So let's just set those up as 20% times 10 parts plus the 5% times the 5 parts will equal our X percent times the 15 parts. Okay, let's double check that our units are all the same. So I have percent all the way across, and I have the units of parts all the way across. So let's drop those units now and just solve for x. So essentially we would have 20 times 10 equals to 200, plus 5 times 5 equals 25, and set that equal to x times 15, which is 15x on the right. So now, reworking that, I have 225 equal to 15x. And if I divide both sides by 15, I get 15. X equals 15. And I'll remind you, going back up and looking at x, the units for x was a percent. So our numeric value of 15 means 15%. And we've solved for x, and x represents the final concentration. When we mix our two ingredients together in that proportion, our final concentration will be 15% of whatever weight we end up compounding. So once again, this slide has hopefully done a good job of showing you that all three of these methods are ways you can solve these questions. We have the algebra method that we've done previously. What we're introducing in this slide set, if you will be the use of the Alligation Medial method, and especially I still find it very useful for a lot of students since it is a visual method. The Alligation alternative method is another very effective way of being able to perform these concentration calculations. Well, let's just work another problem to kind of illustrate, or let's strengthen your skills with this Alligation alternative method, especially when we express things in parts and the way we would express numbers in parts. It's still not a strength for a lot of students in the beginning. So let's work another example where we'll just set up kind of the proportions and talk about relative amounts using parts. The question says, in what proportion should a 30% weight per volume and a 1.5% weight per volume hydrogen peroxide solutions, those two concentrations, what proportions should we mix those two such that we can create and prepare a final 3% weight per volume hydrogen peroxide solution? Okay, so we have a high strength, 30%, and a low strength, 1.5%. And what we want to know is the relative amounts of those two solutions to mix together so we can create something in the middle. And in this case, what's in the middle is the 3%. All right. So I'll remind you, with our Alligation alternative method, what you want to do is start with the high strength. So put the high strength up on top, and our high strength is our 30%, and we'll put that directly above. And so below that, we will write our lower strength, the 1.5%. Remember, right directly below the 30%, and then leaving some space, so that what we can do is write in the middle between those two and to the right our desired concentration. So what we want to have is a 3%. So let's finish up our triangle by drawing our arrows. So an arrow from 30% down to 3% and an arrow from the 1.5% up to the 3%. Now, we'll start with the high 30% and follow our arrows down. So going down from 30% to 3%, let's cross subtract and draw our arrow down. And so the difference between 30 minus 3 is 27. And I'll remind you that when you do this cross subtracting, you lose your units. We're now in parts. So 30 minus 3 equals 27. So the 27 parts, essentially, we follow the arrows down and put it directly across from the 1.5%. Now let's do the same sort of thing for the 1.5%. Let's follow our arrows up from lower right up to from lower left up to the upper right. Let's take our 3%, subtract our 1.5%. So the difference between those two is 1.5. Follow the arrows up, so we write the 1.5 directly across from the 30%. And what we've said up to this point then, what that really means, drawing our line from our 30% straight over to the 1.5, says that we need 1.5 parts of volume to be the 30%. So 1.5 parts by volume needs to be 30%. Similarly, down below, all we've said is that 27 parts of the volume need to be the 1.5%. So remember to draw your line straight across at that point to match up your parts with the right concentration. Okay. And so we know individual parts. 1.5 parts needs to be 30%. 27 parts needs to be 1.5%. But out of how many? What would the total number of parts be? Let's just simply add them up. So 1.5 plus 27 equals 28.5 total parts. So essentially what we have is a ratio on top. Of the 30%, what we really need to know is that 1.5 parts out of 28.5 needs to be the 30%. And in the bottom, 27 parts out of 28.5 parts needs to be the 1.5%. So we've now set up the proportion. We could compound any volume we wanted. As long as we use these right proportions, we could create any volume to be essentially 3% hydrogen peroxide using these set proportions. My last point on this question that sets it a little bit different from our previous example would be to go a little bit further and re-express our concentrations. Don't change them, but re-express them in numbers that look a little bit nicer and maybe easier to handle, because 1.5 out of 28.5 is kind of an ugly number. 27 out of 28.5 is a kind of an awkward value. So can we simplify? Again, not alter the proportions, but simplify the numbers. And I give you a couple of examples down below here, but it may be easiest just to start this way. Let's look at the lowest number of parts, and that would be our 30% concentration, where the numerator is 1.5. That's the smallest ratio in terms of the number of parts. That's an ugly number. Why don't we divide the 1.5 by 1.5, and that would give us 1. That would be a much nicer number. Let's see how the rest of our numbers look if we do that. So again, if we divide everything by 1.5, then for the 30% we would have 1.5 divided by 1.5 equals 1 on top of the numerator. And on the bottom, we would have 28.5 divided by 1.5, which turns out to be a fairly nice number. It ends up being a 19. So now what we can re-express is our 30%. Instead of 1.5 over 28.5, we could call that 1 out of 19. Similarly, if we drop down to the 1.5%, if we take 27 and divide it by 1.5, we get 18. And again, that would be 18 divided by the 28.5 divided by 1.5, which we said was 19. So essentially what we can redo is, by just keeping the same proportions but redoing it, we could restate this as basically saying that we need, for the 30%, we would need 1 part out of 19 to be 30%. And we would need 18 parts out of 19 parts to be the 1.5%. And again, that doesn't change the proportion versus the one that I've shown here on top, but it's often what you would do to make and express your resulting proportions in as simple a numeric values as possible. So there are ways to reduce the numbers down to a nicer value. So again, we have 1 part out of 19 and 18 parts out of 19, meaning the same thing as 1.5 out of 28.5 and 27 out of 28.5. They can be re-expressed in simpler numbers. All right, enough background stuff. Let's actually apply the alligation alternative method all the way through. And so starting here, these are really the format and the process I want you to solve these questions, okay? All the way through. So let's do it. First problem says, how many grams of a 50% weight per weight zinc oxide ointment should be added to 3,200 grams of a 5% weight per weight zinc oxide in order to prepare an ointment containing 20% weight per weight zinc oxide? Okay, so essentially we want to know how many grams of a high strength 50% to add to a fixed amount of the low strength. So we have 3,200 grams of 5%. So this is a little new wrinkle we'll get to here in a minute of the 5%, but 50% plus 5% to make something in the middle, which is 20%. Okay, so let's set up our alligation alternative method. I'm going to do this all at once since we've already done this a couple of times. So I'll remind you, I set my high strength on top, my 50%, over my low strength, which is on the bottom at the 5%. In the middle and to the right, I put my target, which was 20%. So just starting with 50%, following my arrows down, I go from the top left to the lower right, going from 50 down to 20. I cross subtract, and that value would be 30. Okay. Then going from my 5%, working from lower left to upper right, I go up and take my 20 minus my 5, which would be 15, and that's put to the upper right as 15. And now I add up my total parts. So if I get 15 parts from my 50% and 30 parts from my 5%, 15 plus 30 equals 45. So my proportion I'm going to set up on top for the 50% is I need 15 parts out of a total of 45 parts to be the 50%. On the bottom, I show that I need 30 parts out of the total of 45 parts to be 5%. So hopefully you were able to follow that, because that's where we've practiced up to this point. Now what's new is, and this is where it gets a little tricky, we need to start solving for some actual weights. We have proportions. We have the weights of individual ingredients to the total amount. So looking back at the question, what I want to know is the amount of 50%, but I can't start there. What I know, the other factoid that I know, is I know how much of my 5% ointment I'm going to be using. I'm going to be using 3,200 grams of that. Okay, so let's look down below. Remember at the 5%, since that's the weight that I have, my proportion says I need 30 parts of 5% ointment out of a total of 45 points. So let's use that and set up a proportion. We already have that proportion, so let's set that proportion equal to the actual weight of the 5% zinc oxide ointment I'm going to be using. I now know I'm going to use 3,200 grams, and that was of the 5%. So that's the weight that represents 30 parts. My 30 parts will be, the only amount of zinc oxide I'm going to be using, of the 5%, I should say, is 3,200 grams. That represents the 30 parts. So I can set up this proportion of 30 parts of the 5% over 45 parts of the total mixture, equal to the amount of the 5% zinc oxide I'm using, which is 3,200 grams, over X. Now when I solve for X, it will represent the weight in grams of the total mixture, the final mixture, the combined amount that will have a concentration of 20%, but it will be the total weight of that mixture. So if I solve for X and basically take 45 times 3,200 and then divide that value by 30 by cross multiplying and dividing, I solve for X and see that X is equal to 4,800 grams. And I'll remind you, that amount represents the 45 parts of the total weight of the product. Now, I got to remember, that's not really what I wanted to know. What I wanted to know was the weight of the 50% zinc oxide to use. Well, now I can go back up to my top proportion for the 50%. And remember, I have 15 parts of the 50% for every 45 parts of the total weight. And while I don't know the 15 parts weight, I do know that my 45, I've just solved that my 45 parts weight is equal to 4,800 grams. So now I can set up that proportion and say that 15 over 45 is equal to some unknown X amount of the 50% zinc oxide over the total, which I now know to be 4,800 grams. And since I know the 4,800 grams is the total, I can now solve for X by taking 15 times 4,800 and then dividing by my 45. And therefore, I can solve for X and see that X is equal to 1,600 grams. And that is the weight, that X represents the weight of the 50% zinc oxide. So what I've done, we've answered this question, but our final recipe, if we look at that, we see that we need 1,600 grams of 50% zinc oxide. When mixed with 3,200 grams of the 5% zinc oxide, you mush all that together, make it all nice and uniform, the resulting concentration would be 20%, and the total final weight would be 4,800 grams. And that essentially answers this question. Now let's use the alligation alternative method again to solve the same sort of question, but in a unique variation. What we just solved, and what we've used a lot of examples for so far, are solids or semi-solids. We're talking different concentrations of ointments or creams and mixing them together to get something in the middle. And that's great and that works. We're going to do the same exact thing here, but another application where you'll do these sorts of calculations is with your sterile product compounding with IV admixtures. So again, now we're going to be still dealing with percents, but instead of weight per weight, we're now in weight per volume because we're talking about mixing various IV fluids at different concentrations. So the question reads, you need to prepare 250 milliliters of a solution containing 40% weight per volume of dextrose. And the two solutions you're going to use to make that is a 50% weight per volume and a 20% weight per volume of dextrose. And the question asks how much or what volume of each solution would you need to use? Okay, so let's look at what we know so far. So we know that we have a target concentration of 40% and a target volume of 250 mils. To make that final 250 mil total volume, we use whatever volume of 50% we need, added to some other volume of the lower strength 20% to make this final 250 mils that contains 40%. So with that as enough background, let's go ahead and set up our alligation alternative method. So we would start with our high strength on top. So we have a 50% on top over directly above the lower strength, which was the 20%. Our target, which is 40% in the middle, directly in the middle and to the right. So let's start up above with the 50%, follow our arrows down from upper left to lower right, and we cross subtract. So 50 minus 40 equals 10. Do the same thing for the 20%, going from lower left to upper right. Take 40 minus the 20, follow the arrows up, and put our 20 on top there. Okay, and draw our lines across so that we represent the 20 parts goes to the 50%, and the 10 parts goes to the 20%. Now let's figure out of how many total parts. So simply add up our answers together. So 20 plus 10 equals 30. So the actual proportion on top is 20 parts out of a total of 30 parts needs to be the 50% concentration. Whereas down below we can see that 10 parts out of the 30 parts needs to be of the 20% concentration. Okay? And while I don't do this for my math, just so I don't mess with people's minds, yes, you really could go ahead and convert those proportions from 20 out of 30 to equals 2/3 and divide each by 10. And we could express the lower one as 1/3. So we're essentially showing we need 2/3 to be the 50% and 1/3 to be the 20%. But I want to show that you don't have to reduce at this point. We'll leave them in those numbers. Hopefully you can see where those numbers come from, and let's continue on. Okay? Now, what's a little bit different at this point is we know our total volume. We know that the 30 parts total is going to have to equal 250 mils because that's the total volume we want to prepare. That was given to us in the question. Unlike the previous one with the zinc oxide, we know the total, which is the same, the 30 parts for both the numerator for the 50% and the lower one for the 20%. So simply, let's set up those proportions. So starting on top for the 50%, I'm leaving my 20 over 30, and I'm setting that equal to some unknown volume of the 50% dextrose on top over a defined volume of the 30 parts, which is the total, which we want to be 250 milliliters. So now I can solve for x by taking 20 times 250, dividing that by 30, and essentially you would get 167 milliliters of the 50% dextrose. Okay? Jumping down below, let's do the same sort of math for the 20%. So here my proportion was 10 out of 30. And I'm going to set that equal to some unknown volume of the 20% dextrose over, again, the total volume, which is 250 mils. So now I solve for x. I take 10 times 250, but now divided by 30, and I get 83 milliliters of the 20% dextrose. Okay, so this was, I think, a simpler example to solve because we knew what the total weight was going, or total volume was going to be, which was 250 mils, and that was equal to our 30 parts, which was the same for both the 50% and the 20%. So solving for x using those ratios that we did, we've concluded that if we mix 167 milliliters of a solution containing 50% dextrose with 83 milliliters of a solution containing 20% dextrose, our total volume, once all of that was mixed up, would be 250 mils, and the resulting concentration would be 40%. And that essentially answers this question. All right, this next question, I love this next question. I think I'm going to blow some of your minds here because it is almost the same as the previous question and yet very much not the same. And you're going to see solving it is a little more difficult. So let me read you the question and see if you can see where it's the same as what we've just done in some ways. It says, you have already made, okay, that's important. We already now have a 250 milliliters of solution that contains 50% weight per volume of dextrose. And you need to modify this 50% down to, or essentially lower its concentration down to 40% weight per volume dextrose. You have available to do that, we're going to use a 20% weight per volume concentration. So we want to go from 50%, where we have 250 mils of this 50%, we want to lower its concentration. We want to dilute it down to 40% by using a 20% solution of dextrose. So the question asks, find out how much of the 20% solution you would need to use, and by doing so, what would the total volume be after the dilution? Okay? So we'll approach let's just set up the alligation alternative first, and then we'll answer some of the questions. All right. The reason I say that is we are essentially starting with 50%, adding 20% to get a 40%. All right. Well, that is exactly what we did in the previous question. So if I won't re-speak this entire alligation alternative setup, but there's 50% over 20% and 40% in the middle. You cross subtract and you have those same proportions, and we have the same total number of parts. So this question is wanting to go from 50 down to 40 using 20. So the alligation is set up exactly the same. But what's really powerful about this, once you set up this alligation, we can now set this up to answer a very different question because the scenario is different here. Remember, what we have is 250 mils of the dextrose 50% solution. Okay, so now let's start with that. So where we will start to answer this question is with the 50%. Where our alligation tells us we need to make a 40%, we need to have 20 parts of the 50% out of 30 parts total. So now let's set that equal to, since I've got that proportion, what I know in this question is that I'm starting with 250 mils of 50% dextrose. So if I set that equal to on top, I can set that over some total. X equals the total volume. Remember, 30 parts represents the total volume. So since I have 20 parts of my 50% dextrose over 30 parts of total, I can set that equal to 250 mils of dextrose, 50% dextrose, over X. Solve for X, and I now find the total volume of this solution that I'll need to make. So I'll essentially need to have a total volume of 375 milliliters total. Okay. Now that I have the total, or a volume that is equivalent to the 30 parts, I can now use my ratio down below for the 20% to actually solve for its volume, because I can set its ratio of 10 parts of 20% over 30 parts total equal to some X volume of the 20% over the total volume, which I now know is 375 milliliters. So now if I cross subtract or cross multiply and divide and solve for X, I can see that X is equal to 125 milliliters. Okay, and that is of the 20% dextrose. Okay, and that essentially answers this question, which said, how much of the 20% solution would you need to use? Well, we've just solved on the bottom that we need to have 125 milliliters of the 20% dextrose. Because when we take that 125 milliliters of 20%, add it to the 250 milliliters of the dextrose, 50% that we were told we were starting with, that's the combination when mixed together gives us a total volume of 375 milliliters, and that volume would have a total mixed concentration of 40%. Which essentially answers this question. All right, you've made it to the last question of this lecture, and I love this question because it is a redo. We solved the same question in the previous lecture where we solved it algebraically. Now what I'm going to do is solve this question first with the alligation alternative method. Then we will prove our answer or repeat our answer using the alligation medial method to bring this new version of way of doing this home. And then we will, again, finish up by showing you the same way to do it algebraically that we've done in the past. Okay? So with that in mind, the variation on this is, from what we've done in the previous examples in this lecture, is the question says, how many grams of zinc oxide powder, essentially pure zinc oxide, so not a cream or an ointment or something that's a certain percentage, it's pure zinc oxide, should be added to a pre-existing ointment of 3,200 grams of that ointment that has a concentration of 5%. So the 3,200 grams of the 5%, we want to fortify it. We want to increase its concentration so it has a total final concentration of 20% weight per weight. And we're going to enhance that concentration or increase that in concentration by adding pure zinc oxide powder. Okay? So what's a little different than the previous examples here is that we're going to set up this alligation alternative method the same. But remember, on the top left, we always start with our high strength. In this case, it's not a certain percentage cream already, it's the pure drug. Well, we're going to treat the pure drug as having 100% zinc oxide because that's what it is. It is pure zinc oxide. So our high strength is essentially 100%. We're going to set that directly above the low strength that we're adding it to, which is the 5%. And in the middle to the right, we put our target percent, which is 20%. Now, let's just continue to solve this like any other alligation alternative method. Let's take 100, following the arrows from upper left down to the lower right. Let's take 100 minus 20 to get 80 parts. Okay, let's do that from the 5%, going from lower left to upper right. So take 20 minus 5, going up following the arrows. That would be 15. So we have 15 parts of the 100% and 80 parts out of the 5%. Let's add those two together. So 15 plus 80 equals 95. So really, we have on top that we need 15 out of 95 parts to be the 100% pure zinc oxide powder. On the bottom, we need 80 out of 95 parts to be the 5% ointment. Okay? So we have set up our proportions just like we've done before. Really nothing has changed beyond knowing that pure zinc oxide powder would be considered to be 100%. Okay. Now, the way we can go from here is what we're starting with is 3,200 grams of the 5% or the low strength ointment. So let's start down below there and set our 80 parts of the 5% over the 95 parts total equal to 3,200 grams of the 5% zinc oxide over X. Now, if we solve for X by cross-multiplying and dividing, we see that X is equal to 3,800 grams. And remember, X equals the total amount of weight of our final product, okay? Of which 3,200 grams was going to be 5% zinc oxide, and the difference we need to solve for still is going to be the amount of zinc oxide powder we add. Now that we know the total, though, that the 95 parts is equivalent to 3,800 grams, we can go back up to our proportion for the 100%, which said that 15 parts out of 95 needed to be pure zinc oxide powder. So let's set that equal to some X, known as zinc oxide powder, over the total that we just solved for. We know that the 95 parts is equivalent to 3,800 grams. Now we can solve for X by cross-multiplying and dividing, and we see that X is equal to 600, meaning 600 grams of pure zinc oxide powder. That 600 grams needs to be added to 3,200 grams of the 5% zinc oxide ointment, and when we mix all that together, we essentially get a total weight of 3,800 grams that has a concentration of 20%. Okay? And that answers this question using the alligation alternative method, which states that, and again, I'll remind you going forward, our answer was 600 grams of the pure zinc oxide powder. Let's show that answer works using the alligation medial method. So what we'll do is we have the same question here, and we've already solved for our parts using the alligation alternative method. I'll remind you, we determined that we essentially need 15 parts of the pure zinc oxide to be mixed, or the 100% zinc oxide, to be mixed with 80 parts of the 5% ointment. Okay, and we had a total of 95 parts. Let's prove that by doing that, you really do get a final concentration of 20%. So using the alligation medial method, I'll remind you the first step was to add up the weights of everything. So essentially we've done that even though we haven't assigned it to a certain weight, but we had 15 parts of our 100% plus our 80 parts of our 5% ointment, so 15 plus 80 equals 95 total parts. That's our total weight, is we're saying 95 parts. Let's determine the total weight of the zinc oxide by taking its number of parts, which we said was 15 parts, times its concentration, which we said was 100%. So 15 parts times 100% gives you 1,500 parts percent. Do the same thing for the 5% concentration, where we said we wanted 80 parts of that, and its concentration is 5%. So 80 times 5 is 400, so we'd have 400 parts percent. Let's add those together. So 1,500 plus 400 equals 1,900 parts percent. So that's the total weight of our zinc oxide in our final product. So to determine the final concentration, we would take the amount of zinc oxide as 1,900 parts percent, divided by its total weight, which we said was 95 parts. 1,900 divided by 95 equals 20, and the parts units cancel, and we would end up with percent. So doing this, we show and basically prove that if you take 15 parts of 100% zinc oxide plus 80 parts of a 5% zinc oxide cream or ointment, mix them together, your final resulting concentration would be 20%, and we've proved that using the alligation medial method. Lastly, let's confirm our 600 grams that we got using the alligation alternative method, using this and solving the same exact question again algebraically. And I'll try to go through this quickly. We've done some of this before. What we would do is our first mass would be set up as the pure zinc oxide powder that we're using. Its concentration was 100% times its quantity, which we said is unknown. So we're setting that equal to X grams. To that, we are adding the mass of the 5% ointment, which had a concentration of 5%, times its weight, which we knew to be 3,200 grams. So the mass 2 essentially is the 5% times the 3,200 grams. What do we get when we mix those two things together? We get our final mass 3. So mass 3 will be the resulting that we want, the concentration we want it to be in the end is 20%, times its quantity, and I'll remind you this is still where people get a little confused. While we don't know it exactly, we do know that the quantity for mass 3 is going to be the sum of the two things that we're adding together. And since we're adding some X grams of zinc oxide to 3,200 grams of the 5% ointment, the total quantity when we're all done with the mixture will be 3,200 grams plus X grams. Okay, that's equal to mass 3. So in this situation we're taking a mass 1, adding to it a mass 2 to get some sort of equal to some final mass 3. So again, I set up that formula as 100% times X plus 5% times 3,200 grams is going to equal our target of 20% times our total final weight, which would be the 3,200 grams plus X grams. Now, double check the units, percent, percent, percent. Those are all the same. Grams, grams, grams. So I got units the same. Let's drop the units to solve the algebra here. And this is a little more complicated algebra than some of the other ones, so it's always a good idea. Let's drop the units for now. So 100 times X is 100X plus 5 times 3,200 gives you 16,000. Set that equal to, now we have to multiply the 20% times both parts here, so 20 times 3,200 is 64,000, and 20 times X equals 20X. So on the right-hand side, we get 64,000 plus 20X. Okay? You can solve this algebra however you want. Let's subtract 20X from both sides, and I get 80X on the left. I also need to subtract the 1,600 on both sides, so essentially that equals 4,800. So by solving this so far, we have 80X equals 48,000. If we divide both sides by 80 to solve for X, 48,000 divided by 80 equals 600. And remember, look back for X. We said X had the units of grams, so we've solved for X as 600 grams. And we've essentially confirmed our answer with a lot more work and a lot more algebra, but came up with the same answer that we did with the alligation alternative method. So in the end, that's the end of this question and the end of this lecture, but it was a great way for you to see side by side two different ways of being able to solve these questions. The alligation alternative method is a visual way that a lot of students find a little more simple than using the algebra way, although the algebraic method works fine too. It just takes a lot more time and effort to make sure that you set up your formulas right and also be able to accurately, solve your algebra. Either way works to be able to essentially answer the question. If I have a high strength plus a low strength, when I want something in the middle, it allows me to proportion and tell me how much of each of those ingredients to get something in the middle that I want. So hopefully you found this lecture helpful.